Hi everyone, I'm Alok and in today's video we'll be tackling a medium level LeetCode problem together. A little about me, I'm a software engineer with over 10 plus years of experience in development. My goal is to help you kick start or enhance your problem solving skills for coding interviews. Now the reason I choose this particular question is twofold. First, it's frequently asked in interviews, making it highly relevant for preparation. And second, it offers multiple approaches to solve which will help us explore different strategies. So, without further ado, let's dive in and start solving.
Okay, so let's read the description first. Given an integer array nums, return all the triplet nums I, j, and k, such that I not equal to j, I not equal to k, and j not equal to k, and sum of all the three should be zero. One more thing is that the solution should not contain any duplicate values. Okay, so basically we have to find our triplets, such all the integer indexes of those triplets should not be equal, so we should choose the item from different places from the array, and the triplet should be different. It should not be duplicate of each other in the final solution. Okay, let's see the constraint. Array length is basically greater equal to 3 and less than equal to 3. Okay, and nums will have value in the range of, so basically negative and positive both values it will have. Okay, so let's start. I will note down the approach here. So first thing will be quickly find out a brute force solution. If you are unable to get it to optimal, but the the main funda is to find out the brute force solution and then try to optimize it. Okay, so we will start with that only. So as we know from the problem description that we need to find out three values, right? Three values from the nums. So three values or num from the array, right? From the array. And as we know that finding three value from an array, we need three for loops. Okay. Okay, so now we get the three indexes from this for loops, that is I, j, k, and then we will try to sum it and find out whether these values are zero or not, right? Equal to zero. If yes, one triplet we find out, we can add the that triplet as our one in our answer vector. First, so what are the problems with this approach? Okay, first of first problem is creating three loops itself. It takes a big of nq time complexity, right? And then we may find duplicate values, right? We need to handle it separately. And as our constraint, right, since array can have like 3 to the power k length integer values inside it, so big of n cube is not acceptable here. We may need to have another approach. Okay, so let's, so this this is the brute force solution, getting three loops, going through it, and append the result in our answer vector and remove the duplicates from it to get the final answer. But big of nq is not acceptable with the given constraint, so we should look for some another. Okay, so one thing we got from here that brute force solution is not acceptable, but what we find out that we may get some pointer for the final answer from the brute force solution itself. So what pointers we get from this is like here what we are doing is we are iterating, we are having three for loops, right? But we can, if we rewrite this sum check like this, right? Right, this like it's same, right? These two are same statement. So what we have to do is we have to check whether num I plus num negative or num I plus num j itself exists in the array or not. Let me rewrite this. Right, so we have to find out whether negative of num I plus num j exists in array. Yeah, and so this way we can reduce one of the for loop, right? And finding negative of this can be, uh, if we take we use binary search, it will take big of log n, right? Time complexity. And such, so with this we can reduce the overall time complexity from n cube to big O of n square for two loops and then log n, right? But the thing is, let us think whether we need the binary search or not, right? Because if we so for binary search, right, we need to sort the array. Let me take an example with the sorted array. Okay, so before solving any question, right, we should start with a generic example. It should not be like you should not spend much time creating a generic example which is very quite long and all, because it will take you a lot of time to solve the get the solution from generic example. So it should be small enough or not very small enough such that it become a special case, so you should be careful about it. Okay, now I have a example here. Let's start with our second approach, which is using two for loop, right? Two for loop and binary search plus binary search. Okay, so what we are trying to do is we have I one for loop for I, another for j, and then binary search. Suppose I is pointing to -4 here, then j is pointing to -4 here, and then we will find out, uh, try to do binary search in the remaining part of the array, and we try to search for nums I plus nums j, negative of that, that is -4 plus -4, that is -8, negative of that 8. We try to search 8 here, right? Now what I am thinking is like normal binary search, right? That is left, always try to find the mid value and uh, try to get the answer out of it. But what I see here is like if we have -4 already fixed here, then I j can be like start from left, and we rather than uh, having I and j already fixed and then try to do log in search here, right? Try to find out a particular item which is negative I plus j. What we should do is final so find our final thinking is like finding the all the three right items sums to 0. What if we fix the first item and try to do binary search such a way that we will do binary search and try to find two items, right? Two items from this num array, two integers from num array, such that if these two will sum with the third item, it will become zero, like, right? And just now we were talking like we will try to do binary search and try to find uh, the num k, nums of k, right? What I'm trying to say here is we will have one single for instead of two for loops, single for loop for I, nums I basically, and we will do binary search and try to find nums j and nums k, right? And nums k. This way, since we will have one for loop and the binary search time complexity will be added into it. So, but why? The question is why I'm trying to use a modified binary search. This is not a binary search, simple binary search, but modified binary search, right? Where we are trying to find two elements. Normal binary search, we try to find a single item, but modified binary search, here here we are going to find two items. Why I'm talking like this here? This is because like we know that this array is already sorted, right? And we know that we have fixed one of the item like -4 here, for example, and we need two item which is sums to zero. So rather than going through and finding one value, right, what we can do is we can sum. So how do we know that we are going to find an optimal answer from this? So we already know nums I is fixed, nums j and k we have to find. We want nums I. So we are trying to get our solution, find numbers such a way that there some are zero. So we want to minimize the, we want nums I and nums j such a way that it tends to zero, right? It tends to zero. And how do we, so what I'm trying to say is the sum is tends to zero, right? Okay, so that when this sum is added to nums I, it will also generate an answer. And how do we get to know, so from where this start, this solution starts? Okay, so how do we able to find I and j here, right? Which value will tends to zero. So we know that we have I fixed here. What we can do is j can start from just right of the I, and k will be start from the end, okay, in our binary search, such that I plus nums I plus nums j will be zero, because you already know that if the right is the biggest and left we have, if we have integer array with both negative and positive value, and if it is sorted already, then we know that if we add a value which is residing in the leftmost and with the rightmost value, it will tends to zero, right? And then if we add with the nums I, most probably we are going to get the answer. Okay, so basically we are going to move our search from left to right. So this searching range will keep shrinking with each iteration. Okay, so let me, but normal binary search is takes log n time, right? But here, since we will be treating uh, in the worst case we will be trading through all these values, our time complexity for this binary search will be big of n. So basically our final time complexity will be big O of n for the for loop into big O n for the binary search. So it will be big O of n square, and it will be an optimal solution for us, and it will be acceptable here. So how do we proceed is like, let me call the sum of all these three item is sum. Okay, is sum, right? So if we found a solution that is sum equal to 0, in this case, like here, right, if I is at -4, j is at starts at -4, k at 7, sum is -1, right? So in this case, sum is -1, sum is negative, right? So we want positive value. We want our sum tends to like 0. The final sum tends to 0. So we want our nums I plus nums j toward positive value, right? So in this case, we should increment the j, because we already know j is at the negative end at the left side. So if we move toward right, we find positive values, but we will not decrease the k, because um, k is already positive enough, right? If we decrease the k, k is already bigger enough. If we decrease the k, we will find a smaller value, so we will not decrease the k. So in here, in the first iteration, right, the first iteration, I equal to minus nums I is -4. Okay, let me, num I is -4, num I, num j, num k, right? The first iteration nums I is -4, j is -4, and k is 7, and sum will become minus. So we, what we have to do is we have to increase the j. So I is fixed, because we will have a outer loop which will give value of I only. J, we have increased the j, so j will become 2, and value at j will be -3. K will be same. Here sum of all is 0. So when we find a solution, we will not stop here. This is one of the triplet for our answer, but we will not stop here. What we will do is we may find some other num I and j value where the sum can be 0, right? We may find some other triplet also. So in this case, what we'll do is we will increase the j and we will decrease the k, right? Then num I is fixed, -4. Now we have increased the j will be here now, okay, and k will be at here. So 0 and 3, 0 and 3. This will sum to -1. Again, we will increase the j to find to make our solution tends to 0. So we will increase the j here, but we will keep k at 3 only. So here I will be -4, will nums j will be 1, and nums k will be 3 only. So this will end up solution as 0 again. So in this case, we will again increase the j and decrease the k, right? So we, after that, the sum will become negative. So in this case, we will when we end up increasing j, so j and k will both be at the same index. So we won't get any more triplet. So here we found two solutions. With, along with doing this, we may have to push back this triplet. This triplet -4, -3, and 7. Here also we need to push back -1, -4, 1 and 3 in our integer. Now we have found two cases here in which only negative, some is negative and some is positive. But what if sum is greater than 0? Then what we want is we want sum to tending towards 0, right? So we want only decrementing the k. Okay, this will be our approach. We will able to find all the triplets with this. But one thing here is we may find duplicate items in our array, right? So how to fix that? So fixing duplicate, right? Fixing duplicates, because here also you can say we have two triplets pushed back here again. If we start with I as -4 here with the second item of the array, again we will find the same values. But this doesn't mean that we should remove all the duplicates iterating through it. Why we don't want to do is because maybe in the triplet maybe duplicate item will also going to generate some answer, so we don't want to simply remove this. So what we can do is we have the array of array, right? We have an array of triplets basically, which will give the result. We need to remove the duplicates here. So one thing I can think of is set, right? Because set doesn't keep the triplets. So how, what we can do is, instead of pushing back into an array and vector, we should push back, insert this triplet into a set. And then here what we will do is we will iterate through the set and push back the answer, push back the triplets into the vector. Okay, this will be our solution. Time complexity of this, which we already computed here, is big of n square, and space complexity of this will be, since we are going to store this triplet into an set. Okay, max space it can occupy is 3n, right? Or 3n by 3 or something. 3n by 3 triplets it can generate max, because duplicates are not allowed, so it again becomes big of n. Okay, now let's start our coding. So we want a set of vector for our temporary answer. Set of vector, let me call this SVC. We will have a for loop for the I less than num start size plus plus. Now we have this way, the first ith item is fixed, find other two. Here we will call this, what we want is we want two indexes. One is j, which will be greater than I, int k equal to nums dot size -1, right? Okay, now we will do binary search here. What we'll do, modified binary search. So we will have a for loop where this is smaller than k. Let me call sum equal to nums I plus nums j plus num k, right? If sum equal to 0, we found an answer. We found triplet, right? Now what we want is that we want to insert this triplet to answer nums I, nums j, and nums k, and we want to increase j and decrease k. Else case, as if sum is less than 0, we want to increase j only. Else case, if sum is greater than 0, we want to decrease k. This will be the binary search. So this way we get all the triplets inside our set, and we already know set doesn't keep the duplicate. So we have found non-duplicate triplets, but the answer should be in vector, right? So let me create vector answer, and trade through. We already know the type, right? Okay, it's better to vector from the set of vectors, and goes back to the answer, return the answer here. Okay, let me revisit our code and see if we have any issue with the code or not. So we are iterating through the nums total, then j will be greater than I, and k will be the last item of the nums. While j is less than k, we are taking sum is 0, inserting the triplet, decrementing j, decrementing k. Sum is less than 0, we want to make the sum to have more positive items, so increase the j. If sum is greater than 0, we want sum tends to about negate 0, so we will decreasing k. Okay, now let's run this, see how this passes. Okay, there is a compiler sense. Okay, we have to declare the sum. Okay, 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 we forgot to sort the nums here. Nums dot begin, nums dot end, nums sorted. Okay, all are accepted. Let's submit it. Okay, submitted successfully. So you now see how we approach the problem, और मैंने कैसे एक प्रॉब्लम को कैसे एक एक स्टेप से स्टार्ट से कैसे ब्रूट फोर्स सॉल्यूशन क्रिएट किया, फिर ऑप्टिमल सॉल्यूशन की तरफ मूव किया. So I hope you like the video. Let's meet in the next video.